Hello, everyone. How's it going? Just want to make sure you guys can hear me, you can see me well. Just type on the chat, confirm that you can see me and you can hear me. Awesome. Thank you, Doha. Thank you, Mariam, Reem, Judy. Wonderful, wonderful. All right. So today's session, we are going to talk about the basics of chemistry. We're not going to go deep. Things are going to be super, super easy. Thank you, Sharon. Thank you, Mariam. Thank you, Ali. Ed, Sarah, perfect. She says the sound is perfect. Awesome. Thank you, Rama. All right. So before I get started, I just want to know just a little bit about you. I can see your names, but all I want to know today about you is what do you want to be in the future? What do you want to be in the future? Hi from Cameron. I can hear you. See, wonderful, Cameron. Thank you. So, do you want to be a medical doctor, an engineer? I myself, I'm a researcher. I'm a pharmacist. I'm an entrepreneur. I'm a teacher, obviously. An astronaut. Oh, look at that. Doha wants to be an astronaut. That's a job that requires a lot of sciences. Forensic doctor. Ragad wants to be a forensic doctor. Anything related astrophysics. Arwa wants to be an astrophysicist. Dermatologist. Malak wants to be a dermatologist. Lena wants to be a medical doctor. Sorry, my handwriting is so bad. Anasa wants to be an engineer, a software developer, safe. Oh, thank you for wanting to be a software developer. Oncologist. Carmina wants to be oh, Mushira wants to be a teacher. Thank you. Iyed wants to be an engineer, biomedical scientist. Awesome, Sharon. Neurosurgeon, Miriam. Wow, that's a big goal. That's an amazing goal. And guys, I want to tell you something. Guaranteed, all of you will need science, chemistry, physics, biology. An entrepreneur, Adam. Oh, yeah. Yeah. Software developer, Yassine. Okay. All of you will need chemistry somehow. You know why? So medical doctors definitely will need chemistry because your body is all chemistry, right? Engineers will need chemistry because they need to understand material, properties of material, how they behave, right? Reactions. Salma wants to be a doctor. Wow. Okay. Amazing. So thank you for telling me what you want to be in the future. Those are amazing responses. Big ambitions, and I like big ambitions. So keep it up. You guys are going to be amazing doctors, amazing dentists, amazing developers, amazing entrepreneurs, amazing computer scientists. Thank you, Hamza, for letting me know. So how many of you already know me? Some of you, I know some of you already know me. How many of you already know me? Just say me. Mariam. Yes, of course. Mariam is my student. You're here. Amazing. Doha. Yeah, you know me. You know me from your sister. Great. When are you taking your exams, Doha? All right. So two people know me. Everybody else doesn't. So I'm gonna give you a little bit of what I do and who I am. My name is Nirvana Ihab Al Khadragi, and I am a pharmacist. I got my PhD in 2020 in pharmacy practice, and your Fatima's sister. Yes, she texted me this morning. Oh my God, so good to see you here. You know me from your friend. Okay. Yes, she's Dua's sister, Jana. Yeah. I started teaching in 2004 and found my big passion in teaching. I helped hundreds of students achieve high scores. Myself, I was an IGCSE graduate in 1999. Yes, I graduated high school in 1999. Pretty old. I got my bachelor in pharmacy from Cairo University in 2004, and then I moved to the States in 2007, got my PharmD in 2008, master's and then PhD, all from Purdue. Right now, I'm an adjunct professor at Purdue University, and I'm an assistant professor at the University of Wyoming. So science is my thing. I breathe and drink and and eat science all day. It's my passion. I also the author of The Joy of Chemistry. It's on Amazon. The reviews are amazing. I'm so grateful for the reviews. Some people said this is clever, this is cute, it's brilliant, useful book that makes chemistry approachable and look at this, fun. So this is really my biggest goal, is to make chemistry fun. This is my passion, and I want everyone here to feel like, yeah, I like this subject. I'm having fun today. Good news is this book is today, the ebook, the digital form of this book is completely free but only today it's on Amazon. So if you have that digital thing, it's called what? Kindle, I think. You can get it for free. Your name is Lina Hussein, but your device won't. That's okay, Lina. But I'm gonna see the word Omar here, so but that's fine. All right. So, um, what is chemistry the study of? It's the study of what? And can someone tell me why is it so important? Especially people who want to become medical doctors and okay, Yassine, what do you think? What do you think? What is chemistry the study of and why is it so important?
We study about chemicals.
To study about chemicals. And why is it important to know about chemicals?
Like for example, to make to know to make medicines or
To make medicines. Excellent. Mariam, what do you think? Mariam.
So like basically like talks about like as like the previous student said, yeah, it does talk about chemicals, talks about like chemical change and like physical change and like all those stuff, and like it really has like a lot of importance to our like life and stuff, you know what I mean?
Exactly, Mariam. Thank you very much. Sharon said the same thing, to know about how life really works, how life works, how your body works, how material works. So, chemistry, like you said, is important in every aspect of life. Those of you who are going to become doctor, you're going to need chemistry a lot. Engineers, especially surgeons, like you will need to study all about chemistry because you need to understand how things react, how things behave. Now, those of you who are going to become like real scientists, you need to understand, for example, how you do research, how you compare things, how you reach correct conclusions and not make mistakes, how to become accurate, how to expect stuff that didn't happen yet. So yes, scientists can do that. They can look at something, make calculations, and then say, hey, oh yeah, if I mix this and that, I can make this reaction, or I can get this useful medication. Or my sister actually works as a researcher in the University of Illinois, Chicago. And what she does is she creates a medicine, she injects it into animals and then rabbits and stuff, and then she sees if it helps their diseases. So you're in lab work now, cannot speak, that's fine, Sharon, but just pay attention. So chemistry is the study of matter. So when you study about, for example, biology, you will study about everything that is living cells, for example. When you study about physics, in physics, you learn about invisible things you don't see with your eyes, right? So, oh, she's in the lab. Yeah. So if you're studying physics, you learn about things that you don't see. You learn about energy, you learn about waves, you learn about forces, you learn about motion, right? Things you don't see with your eyes. Chemistry, you do study about things you see from the outside with your eyes, but you have to study their insides. Things you cannot see with your eyes, you can see only with a microscope. Now, easy question, everybody answers this. What are the three states of matter that you have to know for now? Yes, people are typing. Thank you, Judy. Yeah, that's one of them. Reem, thank you. Yusuf, thank you very much. Okay, how about Adam on the mic? Can we have Adam on the mic? Doha, thank you. Sama, thank you. Yes, Adam.
Actually, my name is Ahmed and my sister is Reem, but the tablet is getting the name
That's
Adam.
fine. No problem. So, Adam, easy question. Everybody knows this. What are the three states of matter?
Solid, liquid, and gas.
Awesome. Your sister is next to you. That's amazing. So solid, liquid, and gas are the three states of matter. Now, if you Google the three states of, or the states of matter, you will find more states of matter, but do not worry. For now, at your stage, that's all we have to know. Now, I have a question for you guys. Type on the chat or just raise your hand so I can unmute you. Now, since you were a toddler, a little child, you could tell if this is a solid, if this is a liquid, or if it's a gas, right? Since you were a toddler, you could tell. How were you able to recognize such a thing from very, very young age? Solid if it's not moving, that's good. Solid if it's not moving by itself. Jessica says by the texture. Touching it, you can tell if it's a solid or a liquid or a gas. The way it flows on your hand. Yes, Jessica, thank you. The particles of solid. So from the outside, Zaina, Thank you. From the outside, how would you know? When you were 2-year-old, you could tell, right? Solids are hard. Thank you, Lena. Liquid if it's flowing like water. Reem. So Reem is very smart. She's comparing it to water, something we see every single day. She's comparing all liquids to water. So oil kind of flows like water, right? Juice kind of flows like water, right? Gas, most gases cannot be seen, right? So solids, like you guys all said, solids will not flow. So you put them on your hand, it's not going to fall, right? I put this solid on my head. This is my phone. I put it on my hand. It doesn't flow. It doesn't fall. It doesn't make a mess, right? Solids are good because they don't make a mess. They don't flow. All right. What about liquids? Liquids, you guys said, if you put a liquid on your hand, if I pour some water on my hand, oh my God, I'm going to make a big mess, right? Why? Because it flows. It's going to fall from my hand. So it flows. And that's why I knew since I was a child that it is a fluid. And like you guys said, we can just simply compare it to water. That's something we see every single day. Now, what about gases? A lot of you said gases are invisible. We don't see them. So whatever this thing that I'm breathing is actually a gas. Now, here's the news. Some of you already know some gases have a color. Some gases have a color, but usually the gases we are familiar with are colorless. They don't have any color, so we don't see them, but they exist and they have a mass and we can measure them and they can react. You know, what is around us? Around us is a gas, right? What is that gas called? What is that gas called right here? What is that? Yeah, it's called, okay, so a lot of people said oxygen, not just oxygen. What's around us is air, and air is a mixture. We're going to study this a lot next year, is a mixture of several things. One of them is oxygen, and that's the important one. That's the one I need for my body. In biology, you will learn that you take in oxygen. It goes to your lungs. Now, I'm not a biology teacher, but you know, biology is something I love. It goes to your lungs, then it goes to your bloodstream, and then from your bloodstream, it goes to all your cells, and then your cells take in oxygen, and it does a reaction, a chemical reaction in your cells. Does anyone know what chemical? Thank you, Yassine. Thank you, Yusuf. Thank you, Reem. Thank you, Cameron. Yes, Cameron, that's very complete. Thank you very much for your answer. Yassine, Kareem, thank you. Oh, Jessica is asking, is there hydrogen also in air? Actually, no, not really. And if there's hydrogen, it's going to be tiny, minute amount. There's a good reason why there's no hydrogen in air. So I just asked 2 questions. The first question is, what reaction? Thank you. Yeah, that's the correct answer. What reaction happens in your body using oxygen? And my second question is, why is it a good thing that hydrogen is not in air? So the first question, thank you, Anas, for the answer. Thank you, Adam, for the answer. I know it's not Adam, but that's the name I have here. Thank you, Reem, for the answer. That's right. The chemical reaction happening in your cells that use oxygen is called respiration. That's correct. That's correct. Okay, Adam, the next one. Yes, breaking down of glucose. Okay. The next question is, why is hydrogen not in air and why is it a good thing? Why is it a good thing that hydrogen is not in air? Exactly, Yassine, thank you. It's easy to burn. Now there's a chemical, a fancy science name for the word easy to burn. Excellent, Rama. Excellent, Iyad. Excellent, Namis. Flammable. Flammable means easy to burn. It combusts. Thank you, Sama. Thank you, Iyad. Thank you, Reem. Wonderful. Okay. Air also has nitrogen, which is pretty unreactive. It doesn't react with stuff. We also have a little bit of argon. We also have a little bit of carbon dioxide, tiny amounts, not very much. We also have a little bit of helium. We have a lot of moisture, water, right? Where I live, there's very little moisture and the weather is so dry. But in some countries, it's humid, especially in the summer. Water vapor, yes. Water vapor is all around us, which is a good thing, okay? Oh, Aya, you used to be in my class 2 years ago. Oh, that's amazing. I love you so much, Aya, too. Where did you go now? What college are you? All right, so air is gas. It's colorless. We don't see it. However, oh, Iyad, you are Razan's sister. Wonderful, wonderful. Thank you, Iyad. All right, so question. Do all gases have to be colorless? Are all gases colorless? No. Some are colored, okay? And we're gonna study all about this next year. Thank you, Cameron. Cameron gave me a very specific example. Bromine gas is kind of orange, reddish brown color, okay? What else? Does anyone know a gas? Ooh, Iyad, give me one. Iyad, give me one. Chlorine. Now, someone on the chat on the Q&A asked, what's argon? What's chlorine? What are those things? Guys, do not worry. I will teach you all of this next year. Do not worry, okay? We're just doing the basics today, okay? Chlorine is green. Iodine is purple. Thank you, Asim. That's wonderful. All right. No, carbon dioxide is completely colorless. Mustard gas, thank you, Mark. So yes, those gases, some gases have a color. Some gases have a color. And some gases are colorless just like air, okay? So solids, liquids, and gases have some properties. And guess what? Examiners will ask you, even the board exam. Now, this class, this session is most suitable for students. Halogens are exactly, Sumaya, thank you very much. This class is most suitable for students who are still yet to take their board exams next year or after. So June 2026 or after. Okay, I assume everybody is June 2026 or after. So board examiners actually ask about these questions. What are describe the shape of solid, liquid, and gas, and how do you compare the shape of solids, liquid, and gases? You're taking yours in June 2026. Wonderful, Cameron. So Cameron, you may get this question on your exam. So Selma says tightly packed. Some people said stiff. Some people said hard. So on exams, guys, you're not writing any of those. Something else needs to be written on exams. Regular, no. Doha. Tight, no. They're talking about shape. How do you describe the shape of a solid? How do you describe the shape of a solid as compared to liquid and gases? Shape of a solid is fixed. You cannot change the shape of my phone unless you break it. Probably you don't want to, no one wants to do that, right? Or you bend it, right? No one is going to do that. But other than that, the shape is fixed. This is a rectangle thing, right? And it doesn't change its shape. Water does change the shape, right? What shape of, can you say that water is a sphere? Can you say water is a square? No, you cannot, right? What is the shape of water? Or how do you describe the shape of water? How do you describe the shape of water? It's not fixed, right? It's not fixed. Rather, it takes the shape of the container. If you put it in a bottle, it takes the shape of the bottle. If you put it in somewhere else, it's going to take the shape of whatever that somewhere else, something else, right? Now, there's a little bit of a difference between liquids and gases. So in liquids, yes, they take the shape of the container. So this is taking the shape of the beaker, okay? And gas will take also the shape of the container, but the difference between liquids and gases is what? So say, for example, this is the liquid, okay? And this is the gas. What's the huge, both of them take the shape of the container. However, what's the difference? Liquid is more visible. Okay, gas is high. What do you mean by high? I think you're almost there. Gas has a volume. Liquids also have volume. Gas flow up. Okay, someone said it. And Adam also, Safe and Adam. Okay. All right. So about 4 students, or maybe 5 students now, said, and that's correct, that the difference between liquid and gas is liquid is going to stay at the bottom. It's not going to go and flow and fill the whole container. Say, for example, this is water. Water just reached here and stopped. It did not go all the way up, right? Do you guys see in my camera? The water did not go all the way until did not take the whole space. Gas will take the whole space. All right, so that's the big difference. Does anyone know why? So Haneen says liquid have considerably higher density. That's true. But why does gas fill the whole container? Fill the whole container. Liquid will not fill the whole container. Why? It's like one word, 2 words. The volume, density, diffusion, more energy, lighter. Nobody got it. Because the internet, okay, SM got it. So 1 person got it. Actually, John, yes. Rigidity, density, no, not really. That's not really the answer. So Sarah says because gases move all the time. Okay, why are they moving all the time? I actually have a slide for this. Okay, 2 people got it. Kinetic energy, not really. Okay, Mustafa Ramadan got it. Mustafa. 3 students got it. Tense denser. Yes. Yazan got it. Ruqayya got it. 5 students. Okay. So the answer is Yusuf. Thank you. 6 people. 6 people got it. Okay. All right. So the answer is, it has to do with a property that I am. Yes, I see your answers, Judy. It has to do with a property I'm going to talk about in exactly 5 minutes. So pay attention, stay tuned. And the key word is forces of attraction. I'm going to talk about it. Just remember the word forces of attraction. It's not density, it's not volume, it's not energy. It has to do with forces of attraction. All right, so I'm going to get to that. Now, I want you all to give me examples of solids, common examples in your life of solids. Tables, doors, ice, rock, wood, phone, food, wall, diamond, beds, microwave, chair. Look at you guys, paper. Yes, I love it. Okay, so phone, a lot of you said phone. I had a picture of phone, ice, wood, stones, nice, metals, aluminium, pots and pans, things in your kitchen, things you cook with. Pencils, thank you. Someone said pencils. I do have a picture for plushies. Thank you for the example. My kids love plushies. Ice, monitors, yes. The computers we have here. This monitor, my computer, right? Nature, leaves, trees. Can you see my answers? Yes, Malik, I see your answer. And by the way, we also have Miss Dina, Miss Jenna, and Miss Saba, 3 of my amazing assistants here in the Zoom, so you can ask them any questions. And by the way, Jenna is my best assistant, and she is here, right here on the Zoom. I only have the best of the best assistants, so my team is just amazing. So she's here. She was one of my students in the past. She got 196 out of 200 in her chemistry. One of the best, like she is such a high achievers. Tree barks, exactly, thank you. Backpacks, all of these are solids, okay? We can recognize solids very, very easily, right? Example of liquids. Books, Nadine, thank you. Thank you, yes, books are also examples of solids. Oh, liquid, the most famous one everybody wrote water. Some people wrote milk. Some people wrote juice. Soup, yum, I'm hungry now. Okay, thank you very much. Amazing. Example, thank you, Reem. Yes, that's right. Amazing examples. A lot of you wrote amazing examples to oil, also smoothie, yogurt, semi-solid, not really. Soda, bromine in liquid form, yes. Teacher is Razan, a good student. She's amazing. She is amazing. My lovely student, Razan. One of my favorite. Vinegar, thank you, Karma. Exactly. Vinegar. Mercury is a liquid. Exactly. Thank you very much. A lot of students wrote mercury. Coffee, my favorite drink. I cannot give up. No, nitrogen actually, Cameron, is a gas. Okay. All right. Give me examples of gases. That's a difficult one. Air, of course. Methane, thank you. Nitrogen, helium, oxygen. What else? Carbon dioxide, thank you. Carbon, no. Carbon is a solid. Smoke is a mixture of solid and gas. Okay, my PhD was about smoking cessation, so I know all about smoking, cigarettes and stuff. Bromine, yes. No, bromine can be a gas, yes. Krypton, xenon, yeah. Phosphate, no. Chlorine, yes. Oh, Karma Walaiddin, thank you. Are you Nooreen's sister? Nooreen Walaiddin, are you or not? Same last name? Yes, you are. I knew it. She is amazing. Lovely student. All right. So you guys are right. Smoke is a mixture of some solid particles, small solid particles, and gas. So those things coming out of factories, not good things. We're going to talk about that next year when we study about pollution. Those things coming out of factories are gases. When you boil, thank you, Haneen. Haneen said steam. When you, I told Razan you said, oh, Razan, it's amazing. Oh, okay. Cannot wait to teach you, right, Ian? Okay. So when you boil water, something comes out of your boiling kettle. It is steam. Steam. Boiling water is actually in steam form is a gas. All right. So now that we have examples, now that we can recognize solids, liquids, and gas from the outside, now that we know the differences in shape, I want you, and some people make a mistake here, okay? I want you to describe or differentiate the volume of solids, liquids, and gases. Question. Yes, Doha, carbon monoxide is a gas. We're going to study about it next year a lot. And by the way, it's toxic. It kills people. It's bad. Okay, back to our slide here. From the outside, how do you describe the volume of solids, liquids, and gases? Is the volume of solid fixed or it depends? Is it fixed or it depends? Thank you. Everybody got this right. Everybody got this right. Amazing. So proud of you guys. All right, it is fixed. Okay. What about liquid? Some people make a mistake here. Liquid. No, liquid. This one. Liquid. Volume of liquid. Is it fixed or not fixed? Okay, 2 people got it wrong. 3 people got it wrong. 4 people got it wrong. Okay. Question. Do you guys see this number? What does it say? This number. It says, anyone who can see, can you guys, you guys see it. Good. It says 500 ml, which means volume of liquid is fixed. It's fixed. I mean, yes, the shape is different, but it's still 500 ml. You pour it from this bottle to another beaker or another conical flask. It's the same volume. All right. So that's a little bit of a misconception that, or a mistake that I usually see students at your stage. How's it fixed? It doesn't change. So Doha's problem is the shape is not fixed, but the volume is fixed. Yes. So the volume is fixed. You can change the shape. You can squeeze it. If you squeeze, Doha, if you squeeze water, won't the volume just go up? It's fixed. The volume is fixed. Okay. Yes, I can see your chat. Reem. Okay. Oh, if the water spills out, then maybe 100 ml spills out and 400 ml will stay, right? That's a good question. So the volume is fixed. Maybe you can divide it up. Maybe you can drink a little bit of it. If I drank 100 ml of water, then I have 100 ml here and I have 400 ml here, right? All right. What about gases? How do you describe the volume of gases? And this is hard because we're going to learn all about it later. So volume of gases, like you said, for now at your stage on the exam, just write it's not fixed. Later in your AS level and in your A level, you will learn how to calculate the volume of a gas. So the volume of a gas depends on temperature and pressure. And we're going to learn a little bit about temperature and pressure next lesson, Sunday. You guys are all attending on Sunday, right? Next Sunday, okay? I want to see you all. We have 3 more of those, okay? Excuse me, guys. So, but in A level, those of you who need to go to medical school, engineering, and have big ambitions will need to take A-level chemistry. You will learn how to calculate the volume of a gas if you were given the temperature and the pressure. Okay, so it depends. The volume will depend and it will change. Guys, from math, you learned how to calculate the volume of a solid. How do you calculate the volume of a solid? Math, that's not chemistry. Anyone? Math? No. Length times height. Length times height. Yes. 3 measurements. 3 measurements. If this is a solid, for example, you are going to measure the length, measure the width, measure the height, and you multiply those 3 numbers. So it's length times width times height. Math question. It doesn't appear in chemistry exams. Okay. Now, an example of a fixed, Doha said, how is the volume of liquid fixed? So Doha, Dua's sister, do you have a water bottle at home? Do you have a water bottle at home? If you have one, notice how it tells you that if you fill water until here, it's 100 ml. If you fill water until here, it's 300 ml. If you fill water until here, it's 500 ml. So yes, you multiply, Maryam. Okay, Maryam Ahmed, you have a question mark. Why? You guys know there's a Q&A section where you can ask whatever question you have and Miss Jenna will answer you. Okay. All right. So that's from the outside. We learned about solids, liquids, and gas from the outside, how they look like, how you recognize them, examples of them, how do you describe the volume of them, how do you describe the shape of those things. Now we want to talk about, yeah, I'm gonna unmute you, but at the end, okay? Let me just, do you have a question or do you want to answer things? You probably just want to answer, right? Because you're such a good student. Yeah. Okay, so now we want to talk about, you want to answer? Yeah. Now we want to talk about the inside, okay? The inside. So Iyad, at this stage, today's lesson, we're gonna talk about the inside of solids, liquids, and gases, and we're gonna call them particles. But do you know what these particles are actually, what they are made from, which we will learn about next year? Iyad, do you know? Atoms, thank you. Protons,
Hello?
yes, Iyad. What are they made from? Those particles.
Particles.
Yes.
Particles are made of atoms.
Atoms is an example. What else? Do you know anything else?
Atoms and
So Safe said elements.
electrons.
So electrons are inside atoms. We're gonna take this later. Okay.
Okay.
All right, wonderful. Thank you so much, Iyad. So Iyad said atoms, and a lot of you said atoms. Thank you, Yazan. That's right. So they could be atoms, they could be molecules, they could be ions, and we're gonna learn all those details next year. Okay, so we're gonna talk all about atoms. We're gonna talk all about molecules. So molecules is like when you have more than one atom, and then we're gonna talk about ions. We're going to talk about isotopes, which is a kind of an atom, Zaina. Thank you very much. Now, do you guys know what is the most famous molecule on Earth? 75% of Earth is made of this molecule. What is that molecule? 75% of Earth is made of this molecule. Excellent. Water. Does anyone know the formula of water? Already 5 of you wrote the formula of water. That's amazing. Yeah, the formula of water, and water is a molecule. We're going to talk about what molecules are, what elements are next year. The formula of water molecule is H2O, and we're going to learn more about it next year. It's in my opinion, it's the most amazing, wonderful molecule on Earth, in my opinion. All right, so examiners, Sama agrees. Thank you. Okay. Examiners like to ask you to draw sometimes. Sometimes they will say, hey, draw the structure of solid, or draw the structure of liquid, draw the structure of gas. How do you draw the structure of a solid, for example? Solid would be, okay, Reem said, tightly packed, thank you. So it's really simple. Tightly packed particles, okay. It's really simple. All you do, thank you, Sama, very much. All you do is you draw circles. But in solid, I want you to draw the circles in order, okay? Very regular, very tidy, and tightly packed. They are all close to each other, no spaces, okay? No spaces. So solids look kind of like this, and you draw this on the exam. Make sure all the particles have the same size. You draw this on the exam, and boom, you get the mark, okay? What about liquids? What about liquids? So say, for example, this is a beaker. This is a liquid. It's flowing. Also circles. But thank you so much, guys. They're not tightly packed. They are loosely packed. Some of them could be touching. Some of them are close together but not touching. And they can actually move around. So this is how you draw liquid. Okay, so these are circles. Also, please make sure they are all about the same size. And boom, you get your mark on the exam. And these appear on board exams, right? Yeah, spaced out a little, closely packed. Some of them should be touching. So make sure that some of them will be touching each other. Okay, not all of them separated. What about gas? Say, for example, this is a big container, a big room that has air in it. How would you draw the circles? Thank you, Yazan. Far apart, completely far apart. one particle here, one particle here, one. Now, if you have them touching each other, are you gonna get the mark or get a 0 on the exam? If you have the particles touching each other, do you get the mark or do you get 0? Thank you very much, Iyad, Sama, Reem, Nadine, Hannes, Ahmed. 0, you get 0. If you have particles touching each other in gas, you get a 0. Thank you so much. Okay, next question. Examiners may ask you about the separation of particles in solids, liquids, and gases. How are particles separated from each other? What is the word, the key word you write on the exam? For solids, are they separated? I'm not talking about melting. I'm talking about how are the particles separated from each other? Are they separated? Thank you, Jessica. Or are they not separated? Thank you, Mark. They are very close. On exam, I want you to write tightly packed. Tightly packed, okay? They are very close. They're very close together to a point where they are tightly packed, okay? Thank you, Basil. Thank you, Reem. What about liquid? What about liquid? Loosely packed, thank you. Loosely packed, and most of them are touching each other. What about gas? What is the word you're gonna write? One word, 3 letters on the exam to get the mark. Far, thank you. Far, far, far. They are really far from each other, and they take the largest volume, okay? All right. I have a question for you. You guys all told me the formula of water, right? You told me that the formula of water is, water is H2O. Question, how many atoms does water have? How many atoms does water have? Thank you, Iyad. Thank you, Adam, Sumaya, Abdurrahman, Asim, Mark, thank you. Okay, some people said 2, but most of you said 3. We will learn this next year. Thank you, Sarah. There are 2 hydrogens because there's the number 2, this little small number 2. We're going to learn all about it next year. There are 2 hydrogens. Thank you, Sama. 2 hydrogens and 1 oxygen. So total, we have 3 atoms, right? Total, we have 3 atoms. Oh my God, Malak here. Malak Azmi is here. I miss you too. Yes, I can see your messages. Hello. All right. Now, let me draw liquid water and let me draw gas water. Oops. Where's my, okay. Let me draw gas water. Okay, gas H2O. So say, for example, this is the container that has liquid water. Oops. And I'm going to draw similar container. I'm going to copy paste this thing. All right, so let's copy this and paste it here. And in the first one, I'm going to draw liquid water. And you guys said that it is circles. It is circles. They are touching. They are close to each other. They are loosely packed. And yeah, very close to each other. So here's the water. Now, the reality of each circle is basically H2O. Sama, that's correct. Each circle is H2O. So each circle has 3 atoms, basically very, very tiny. It's very small, right? It's a molecule with 3 atoms. What about gas? How do I draw gas? We just said it has to be far from each other, okay? And each of them is basically H2O and H2O. And my question is, does the size of water particle change when the state of matter change? Iyad, guess who? Thank you. The person said his name on Zoom is called guess who. Okay, I'm gonna repeat the question again because half of you got it wrong. Okay, does the size of the particle change depending on whether it's a liquid or a gas? So the size of this particle, let me highlight it in orange. The size of this particle, the size of water. This is the size of water in liquid. This is the size of water in gas. Does it change? Does it change? So water is small in liquid form, and is it big in gas form, or is it big in liquid form? And thank you, Iyad. But does the size change? I still have half of you get it wrong. So guys, water is how many atoms? We just said water is 3 atoms. It's 3 atoms in liquid, and it's also 3 atoms in gas. Does it magically change its formula and become 4 atoms or 5 atoms or 16 atoms? No. Thank you, Mark. It's the same size. It just takes more space. Yes, the molecules will take more space. However, each particle will have the same size. There are 2 EADs. Yes, I know there are 2 EADs. Okay. So yes, that's right. The size of the water stays the same. They stay the same. The size of the particle stay the same, whether it's liquid, solid, or gas. It's just the separation of them that's different. Do you guys all get it? Do you guys all get it? Nadine said, no, I don't get it. Size 2. Okay, Nadine. Nadine. How many atoms are in water in liquid form, Nadine? In liquid form. How many atoms are there? 3. Okay, Nadine. In gas form, how many atoms are in water? In gas form. Karma, same question. Also 3. So Karma, Walaiddin, and Nadine. Since water is 3 atoms in solid, 3 atoms in liquid, 3 atoms in gas, the particle itself does not magically become bigger or smaller. Do you get it now, Nadine and Karma Walaiddin? Karma and Nadine, do you guys now get it? Nadine gets it. Good. Karma, thank you. Good. Karma, you're behaving just exactly like your sister. She's like, oh, your sister does that. Okay. Wonderful. Okay. Oh, by the way, Miss Dina just posted my phone number. If you guys want to contact me, if you guys want these notes after the lesson, please get in touch so I can send you the notes. Okay. All right. Okay. So this question about the size of the particle is in the Kahoot. So make sure you answer correctly. Okay. All right. Now, my other question, which confuses it confuses students a lot. This is a little bit of a tricky question. My other question is, if I have a fixed volume, okay, for a solid, a liquid, and a gas, okay, yes, there's a Kahoot today. Yeah, and there are 15 questions. I made it very short. Each question is only 30 seconds, sometimes 20 seconds, okay? Sama, Iyad, Sama said, okay, so if the volume is the same, which state will have more particles? So say, for example, this is a cube that has a solid. This is a cube that has liquid. Excellent, guys. Excellent. Dima, Asim, Yasin. Wonderful. Malak. Yeah. Jessica. This cube has a gas. Now, I'm going to draw this cube in the form of a square just to simplify things. Okay? I want you to tell me which cube will occupy the most or will fit the most particles, solids, liquids, and or gases. Say, for example, this is a solid. Okay, how many particles can it fit? Let me draw the structure of solid. What do we know about the structure of solid? Tightly packed, regularly arranged. Maryam, I can see your answers. Okay, you answer right here. Okay, here are the particles. Okay, how many particles can I fit? What do you think? How many particles did I fit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Saifuddin, thank you. Okay, or Sif Mamdouh, I was able to fit 12 particles in this square. If I have square of the same size, same size, and it is a liquid, how many particles can I fit? How many particles can I fit? What do you know about liquid? Loosely packed, touching, right? So it's loosely packed. So let me make it a little bit loosely packed, right? A little bit of space, all right? How many particles did I fit here? 1, 2, 3, 4, 5, 6, 7, 8. I was able to fit 8 particles, okay? So the question, remember, if the volume is the same, which state will have more particles, all right? And then if it's, thank you, guess who? What about gas? How many particles can I fit? Remember, gas particles are far from each other. So one particle here is here, one particle is over, like max, maybe 3, maybe 4 maximum. Okay, so I could fit 2 to 3 particles in the same volume for gas. So what is the answer? If the volume is the same, which state will have the most particles? Of course, solid. Do you guys all understand? Everybody understands this. Wonderful, 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 wonderful. Awesome. Awesome. Look at you guys. This group is very smart. This group is very smart. Okay. Next question on exam. Yes, examiners ask about these things. They're asking about the arrangement of particles, the arrangement, okay? Not spaces, not separation, not energy, not movement, arrangement. Are they regularly arranged or are they all over the place, randomly arranged? Thank you. What about solids? Solids are regular. Solids are regular. Each particle has its place. Nothing random here. What about liquids and gases? Oh, liquids and gases. These people are just moving randomly. They have random places. There's no arrangement really, right? So liquids and gases are random. Or yes, Yasin, you can write, or Yazan, sorry, you can write irregular or irregular. Okay. So yes, Ahmed Khalid, you can do that. Okay. All right, what about motion? Motion is movement. How do these particles move? Yes, I can see your answers, Iad. Okay. Yes, thank you, Muaz. Thank you, Jessica. Restricted. Okay, so for arrangement on the exam, Jessica, just write regular. Okay, for solid, random or irregular for liquids and gases. Now, guys, how do you describe adults? Now, I think all of you here are teenagers, unless some of the mommies are attending, which is great. Love it when mommies attend. Love it when teachers attend. Please have them attend my sessions. How do you describe adults? You as a teenager, I have a teenager at home, okay? And, oh, Yazan, my teenager is bigger than me. She's taller than me. But you know how she describes us as adults? Thank you, Mariam. Mariam, oh my God. Mariam says we are lazy. Okay. Slow to move, Muaz says. Oh my God. Okay. So my daughter says that we work all the time. We're on our computers all the time. You guys are right. Adults are kind of stationary. Oh my God, Hamza, you know what Hamza said? He said they are always tired. Okay, except me. I'm an exception. Okay. So adults usually sit on their computers, right? So that's very similar to solids. Particles in solids do not move. However, they vibrate. They do not move, but they do not move like this, but they vibrate in their positions. So yes, they are in their positions, sitting on their computer. Now, guys, on the exam, do not say sitting on the computer, okay? You write they are vibrating in their fixed positions, okay? So solids are kind of like adults, okay? And now I want you, so on exams, I want you to write that solid particles, if they ask about motion or movement, okay, you guys have to read the question. Read the question, okay? So solids vibrate in their positions. Can we say movement is restricted? Jessica, write this, vibrate in their fixed positions, because that's what we have. Now, if you do write the movement is restricted, you may get the mark, but the word vibrate is missing. And usually in mark schemes, they write the word vibrate. Okay, so Jessica, stick to the mark scheme, stick to my method. Okay, so Jessica, some of my students got full marks. Okay, because they stick to my terminologies. Nadine, vibrate is like this. Movement is like this. Do you get the difference, Nadine? Nadine is asking what's the difference between vibration and movement. You guys know when your phone vibrates? You guys know when your phone vibrates? Is that a vibration or a movement? Movement means like this. Movement means it's moving. Our phones don't move, but our phones vibrate, right? Okay. I almost broke my phone. Next is liquids. So liquids are like you guys, teenagers. How do you describe teenagers? They move, right? They go to the malls, they go to the movies, and they kind of move around. Not fast, kind of slow, but they do move, right? They do have some kind of movement. That's exactly like liquids. So they're social. Yes, Yazan, that's right. They're social. They move. And they're like liquids. So how do you describe the movement of liquids? They move slowly. They slide over each other. Slide over each other. That's because they're touching. So they're moving and they're sliding over each other. Easy to write on exams? Excellent, Ali. Thank you. All right. What about gases? Now, gases is similar to what? Thank you, Ahmed Khalid. You know where I'm going. Thank you, Doha. Excellent. So solids are like adults. Liquids are like teenagers. Gases? Oh my goodness, those are like what? toddlers, they are all over the place. They're not walking around, they are running around, right? They are running, they're all over the place. And that's exactly like gases. Gases are really fast. So they move fast and random. Do you feel like toddlers know where they're going? No, they move randomly. They go wherever, right? When my kids were toddlers, oh my God, it was so hard watching them. All right, so now this is about motion. So examiners may ask you about separation. Do they bump it? Yes. Examiners may ask about drawing. They may ask about separation. They may ask about arrangement. They may ask about motion, how they move. Or examiners may ask about energy. Energy. How do you describe the energy of adults? Yikes. Except me, I'm an exception. I'm energetic. But in general, you see adults, Hamza said, they are always tired, very low energy. Right. Same with solids. Same with solids. Solids have very low energy, and that's why they only vibrate. They don't move. Okay? They don't have much energy. What about liquids? Those teenagers. Oh yeah, you guys have energy. You guys will do my homework. You guys will do my work. You guys are energetic. Thank you, Mark. Okay? What about gases? Toddlers. Toddlers. A lot of energy. These are the high-speed moving kids. You go everywhere. Okay, now I have a question for you. If you want, now we usually don't, parents do not like that, but if you want the kids, and more heat gives more energy. Yeah, if you provide them, Mark knows where I'm going. Mark Sameh, he knows where I'm going. If I want my toddlers, not something I do, of course. If I want my toddlers to move faster, to have more energy, what do I do? If I want my toddlers to move faster and have more energy, what do I do? Give them candy, right? Worst thing ever. Give them sugar. And they're like, blah, 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 right? You cannot catch them. Thank you, Karma. Chocolate, exactly. Okay. Now, what about particles? If we are, thank you, Minatullah. If we are talking about solids, liquids, and gases, we're not going to give them candy, right? It's not sugar. Something else. Thank you, Iyad. He says Red Bull is the word. Energy drinks, you don't want to do that either. Exactly. Give them heat. If you provide heat, it's going to give them a lot of energy. All right. Now, how do we provide heat? By putting it on the stove, right? Putting particles on stove. You just provide heat, right? I think I have a heat source here. No, I don't. I used to have like this lighter. Okay. So if this is a rule, if you increase temperature, particles gain energy and therefore they move faster. Okay, particles gain energy and therefore they move faster. And this is important, very important. And I will ask you about it next year again. Okay, so let's see. Hala, that's right, Hala. All right. Or is it Hala? Hala? So H-A-L-A can be pronounced Hala, Hala, or Hala. You better write it in Arabic so I understand how you pronounce your name. Okay. All right. You guys remember a few slides ago, as you increase the thermal energy, gain kinetic energy. Hala. Okay, great. Thank you for letting me know. Okay. You guys remember a few slides ago, and I said I'm going to ask you again, and I said there's this keyword. Okay, when I said that the shape from outside, liquids do not fill your container, but gases fill your container. Now I'm going to answer why. Anyone who knows why? Anyone who remembers that one word that I said briefly and fast? Seems most of the things you, Anas, I don't know what you, okay, gases for excellent. Look at you guys. Look at you. That's right. That's right. That's right. So the reason why liquids take a very specific volume, but gases take the whole volume is that forces of attraction are different. How do you describe the forces of attraction of solids and that of, thank you, Sharon. Thank you, Sumaya. So how do you describe the forces of attraction of between particles in solids, in liquids, and in gases? So how do you describe forces between particles in solid? Oh, Sama said intermolecular. Not always. Okay. Next year again, when you are in your, in your serious year, we're gonna talk about the different forces of attraction. Okay. So these particles have strong forces of attraction, and that's why they are very close to each other. Okay, strong forces of attraction, and that's why they are very close to each other. Okay, so Sama said intermolecular forces. Not always, they're not always called intermolecular forces. They're called intermolecular forces if they are covalent, something we will learn about later. Okay, sometimes it's a covalent, it's an ionic force. Okay, all right, what about in liquid? In liquid, particles are touching, they are loosely packed, right? The forces of attraction are a little weaker. There are forces of attraction, but they are a little weaker. Okay. What about gases? What about particles in gases? And they are far from each other. The forces are very weak, very weak. And that's why in gas, the particles are so far apart. That's what explains why they are far apart. Now, how do you describe this on exam? How do you describe this on exam? Solids have strong forces of attraction between particles. Liquid have still strong forces, but less strong. Can you explain what forces are real fast? Okay, Jessica. And gases have very little forces of attraction between particles. So Jessica is asking, what are forces of attraction? Now, I have a question for you before I talk about this. Are forces of attraction the same thing as bonds? Are forces of attraction the same thing as bonds? Yes, no. On the chat. Yes, no. Nadine, thank you. Okay. Sumaya said yes. Miriam said yes. Saifuddin said yes. Okay. Okay, Ali, can you remind me at the end? Okay. Forces of attraction are not the same thing as bonds. They are not bonds. They are not bonds. Forces is something that's keeping the particles close together. Jessica asked, what are forces exactly? We're going to learn this. So there is something called intermolecular forces of attraction. That's when water is close to another particle of water and they are kind of close to each other. Something is keeping them together, right? And this something is usually opposite charges, okay? In your A level, you're going to go deep into this. You're going to take all the details about what those forces are. But the strongest force is when we have opposite charges. So if you have something positive and something negative, what do you expect? What do you think? Boom! They are very close to each other. They're so attracted to each other. Okay? Easy? All right. So for now, at this stage, if the examiner asks you to describe the forces of attraction between particles in solid, you say that the forces of attraction are strong. In liquid, are less strong, but they're still strong. In gas, almost no. We say now almost no, but later you will learn different kinds of forces of attraction. Very, very, very weak and very little forces of attraction between particles. Yes, those are different, Cameron. Yes, those are all different. All right. Okay, good question, Cameron. All right, and that's why particles in the liquid will not fill the whole container, but particles in gas will fill the whole container. So, for example, this is a liquid, okay? And here are your particles. Here are the particles. And this is your gas. I'm going to copy paste this. Copy. And I'm going to draw the same exact number of particles. How many particles did I draw? 1, 2, 3, 4, 5, 6, 7. Okay. But I'm going to draw them very far. Okay. 1, 2, 3, 4, 5, 6, 7. What's the difference? The difference is that these forces between particles are strong. Okay. These forces between particles are stronger. Probably because something to do with the charges, which we will learn later in the A levels. Okay. They don't teach this until A levels. In gas, the forces are weak And that's why the particles are so far from each other. Okay, if the examiner asked the question, but with 2 questions, how can we write the second point? Oh, great question. And I always get this question in class. You're going to say, okay, so usually they will not ask about liquid unless they compare it with something else. But if they ask you about the liquid without comparison with something else, you're going to say strong forces of attraction, but less strong than in solid. Okay. And that's why in gas, because they're so weak, the particles just fly and go everywhere. Nothing is keeping them together. Okay, nothing is keeping them together. These forces are keeping the particles close, to each other. All right. Who likes summaries? What I taught right now until now, 21 slides. I taught 21 slides, and I'm going to put all 21 slides in one slide. Yes, I like summaries a lot too. And I'm going to give you my summaries of your of all the content. So here's the structure. Here's the separation, arrangement, motion, kinetic energy, forces of attraction. Next time I will teach you something called compressibility. Okay, so that's for next time. And I was gonna teach you something about math today, but we're over an hour, but I will teach you these math concepts next time. Who likes Kahoot? In gases, forces are non-existent due to the reason the particles are moving free. Okay, so yeah, Sayed, they are moving freely because of weak forces. Okay, all right, you guys know Kahoot? Okay, wonderful. So before I talk about Kahoot, I just want to let you know that I am giving away my notes completely free. Just text me on WhatsApp. You can text me here. Just scan this QR code or go to this phone number. I'm gonna give you my notes. Just tell me what your board exam is, and I will give you my notes. I'm also giving the summaries for free. So these are the whole syllabus. Every single thing you need to know. All the content in 12 pages. Very concise and very, very helpful when your exam is the next day. Okay, so make sure you guys catch my phone number. Sama says, I love your notes very much. Wonderful. The next sessions are going to be next Sunday, February 9. Thank you, Nadine. February 16, February 24, and August 14. August 14 is going to be the start of a new course. Make sure you are here August 14. Okay, this is the start of a new course. So make sure, and it's much faster, okay, because this one is a bit slower. All right. Miss here so much. Jana Abdelati, do you want to say something? She said miss here. Okay. So text me if you want me to remind you of these sessions. All right. Okay. Let's now go to Kahoot. Oh, you miss her so much. All right. Let's go to Kahoot. And what I want you to do is I want you to go to kahoot.it. Kahoot.it. Oh yeah, we missed Dua. Oh, Sama, that's wonderful. Which year are you, Sama? Try to put your real name. I would love to. I mean, if you don't want to put your real name, that's fine. But if you put your real name, I would love to see your real name here. Okay. All right. So go to kahoot.it and put this PIN number 7515837. Okay. What should Malak? What are you saying? What should I type? Your name. Just type your name. So Rama is here, Sama is here, Zaina is here, Salma is here, Atam is here. Yeah, wonderful, wonderful. Okay. Those of you who have their hand raised, do you guys want to say something?
I wanted to ask, is it better if I study from your notes or from the textbook?
My notes. I mean, reading the textbook is wonderful because it kind of, you know, gives you all the details. My notes are enough. For exam purposes, notes. Great question.
Okay, thank you. Wait, I have another question, sorry.
Sure.
But I wanted to ask this from before. If chlorine is a gas, then how is it added to pool water?
If chlorine is gas, how is it added to water? A little bit of chlorine dissolves in water. Now, this is a great question. You will study this in A level. Chlorine slightly dissolves in water, a little bit of it dissolves in water, and it also undergoes a reaction, which you don't have to know right now. I'm going to teach you this reaction, do not worry. Great question, very smart. I love people who are focused. All right,
Thank you.
Ali, do you have a question? Ali Fudail, do you have a question?
Yeah. I have to open the book because I forgot about it. Just
You
give me
forgot
1
about
second.
what?
I forgot the question. My teacher did not answer the question in school, so I wanted to ask it to you.
Okay, once you
Just-
remember the question, ask me. And do you have my phone number?
Yeah.
Wonderful. Okay. You can ask me. You can ask. You can put your question in the Q&A, or you can unmute and ask me. Iyad, Salma, do you have questions? Hamza, Doha, any questions?
No, I don't.
Okay, no questions. No problem. Okay.
Yeah.
Miss, I forgot to put down my hand. That's it.
You forgot to do what?
To just put down my hand. That's it.
Oh, no problem. Okay, yes, you guys can put down your hands if you don't have any questions. Melek, go to your website. Go to whatever. Do you use Chrome? Do you use Safari? Whatever you use, just go there, and in the browser write kahoot.it. It's gonna ask you for the game PIN number. Put this PIN number. Put your name, and you're gonna be in. I want you to learn this app. It's wonderful, guys. It's a really good game. I use it in my class a lot. Okay, any other questions before we start the game? We have 83 people in the game, so let's get started. Salma, do you still have a question? Your hand is raised.
Our board is the AQA, so for the next course, will it be AQA?
Yes, I have AQA available. Just
Okay.
text me, and I will send you the notes. Study from my notes until we meet next year, okay?
Okay.
You have my number?
Yeah.
Wonderful. Okay. All right. Yusuf, that's a great question. I know Jenna is answering you, so that's amazing. All right, you guys ready? Can we start? We have 15 questions. You've got to be very quick. Read the question, answer it within 20 to 30. Some questions are 20 seconds, some questions are 30 seconds, and a couple of questions are 45 seconds. Okay? Ruqayya, you want to ask a question?
Yes. Do you give the IGCSE curriculum and the A level, international
Yes.
A level?
Yes.
Thank you.
Yep, you're welcome. Just text me so I can send you a reminder mid-August. I start my courses early, guys. I start my courses mid-August. I don't start in September. I start early because I have a lot to teach. All
Okay,
right.
Is
Go
it
ahead.
Edexcel?
Edexcel, yes.
Okay, thank you.
You're welcome. All right, let's get started. And once I get started, you will see the pin at the bottom of the page, so you will still have it. You will still be able to join. This is going to be so much fun. All right, so 3, 2, 1. Awesome, Yusuf, that's amazing. Go. What is chemistry the study of? Okay, simplest question. You have 30 seconds. Come on. Matter, numbers, shapes, plants? Okay. Easy question. Okay, so of course, chemistry is the study of matter. Thank you. 88 got it right. That's amazing. Look at you. This group is, oh my God, this group is smart. This group is smart. All right, here's the chart of the top 5. I'm proud of all of you guys, not just the top 5. Which are the 3 states of matter? Easy. So I started with 2 easy questions. The 3 states of matter. Wow, all of you answered in like 20 seconds. 10 seconds, actually. Ooh. Oh, I mean, this group is amazing. Okay, so of course, the 3 states of matter are solid, liquid, and gas. Okay, all right, 8 seconds. I think everybody answered. 6 seconds, 5, 4. I clicked the wrong option by mistake. Yes, it happens, Lena. That's fine. That's fine. Okay, all right, next one. So here's the chart again. True or false? Solids have fixed shape and volume. True or false? Oh my God, look at this group. So amazing. All right. So true or false? Solids have fixed shape and volume. So you guys got 6 seconds. 3, 2, 1. Awesome job. Yes, of course, solids have fixed shape and volume. Look at the scoreboard. All right. How do liquids behave in terms of shape? Shape of liquids. Shape of liquids. Red one says fixed shape, but the volume depends. Okay, guys, remember my bottle of water. Read this carefully. Fixed shape and fixed volume. Blue. Yellow, neither shape nor volume are fixed. And green, fixed volume and fixed shape and takes the shape of the container. So the blue one says fixed shape. Okay. I mean, yeah. Ed, you have your hand raised. I don't know if you wanted to talk or what. Or is it, you picked the
Teacher,
wrong one. Okay.
I picked the wrong one by mistake.
Yeah, I know. Mark also picked the wrong one by mistake. Yeah, it happens. We're learning. We're learning. It's fun. Guys, we're having fun. So yes, fixed shape, fixed volume, I mean, but it takes the shape of the container.
Teacher,
All
I was
right.
first place, now I'm 54th.
Ah, what are your, okay, it's okay. You can make it. Focus. How are particles arranged in solid? How are particles arranged in solid? Arrangement in solid. Randomly packed and touching, solid, okay? Far apart and random. We're talking about solid. Tightly packed and regular. Loosely packed and oh, look at you guys. Excellent. Tightly packed and regular, of course. Only one person probably clicked wrong. I love this group. It's amazing. Okay. Question number 6. How do particles move in a liquid? How do particles move in a liquid? They slide over each other slowly, they stay stationary, they move randomly with high speed, or they vibrate in a fixed position. Okay, I gave extra time here. You clicked on the wrong answer, Sema. Oh, yes, they slide over each other slowly. It's a liquid, okay? All right. Question number 7. Which state has the highest kinetic energy? So much energy bumping into each other, moving all over the place, just like toddlers. I only remember it from your example of the teenager earlier. Cameron, amazing. So proud of you. You clicked the wrong answer, Iyad. Iyad, focus. Slow down. Slow down. Okay, 10 seconds. Wonderful. Highest kinetic energy. Gases, toddlers. My goodness, all over the place, right? Okay. Question number 8. What happens to particles when temperature increases? You provide heat. You increase the temperature. They stop moving. They lose energy and move slower. They gain energy and they move faster, or they become larger. The particles become larger. The toddlers in the candy. Exactly, Cameron. Exactly, Cameron. Okay. All right. Wonderful. They gain energy and they move faster. Look at you guys. Okay, this has double points. True or false? Size of water molecule becomes bigger in a liquid or is bigger in a liquid than in a solid. And this question has double points. Size of water is bigger in liquid than in solid. True or false? Let's see if you guys still remember this part. And I know it's a bit like hard to understand, but hopefully we all got it. Okay, 8 seconds. 5 seconds. True or false? 3, 2, 1. Okay, it's false. The size stay the same. The size of the particles stay the same. The spaces change. The spaces between particles are changing. Okay? All right. Those of you who got it wrong, was that a misclick or which state has the strongest force of attraction? Strongest force of attraction. So close to each other. They're staying very, very close to each other. Solid, liquid, gas. And then number 4, I just had to put another state of matter, which you don't have to know anything about. Yes, solid. Wonderful. 35th place. Yeah, that's okay. This is a large group because it's a free session, so it's okay. You accidentally do it by mistake. Okay, in which state do particles fill the entire container? They fill the entire container. This is easy. They fill the entire container. Solid, liquid, gas, all the above? Okay. All right, which one? Oh, Hala, you pressed wrong. It's okay. Guys, we're having fun, okay? So, of course, it's gas. Number 12. What is the arrangement of particles in a gas? Arrangement of particles in a gas. Loosely packed and touching, random and far apart, regular and tightly packed, regular and far apart. Okay, you guys, I think you got it right this one, right? Okay, 18 seconds, 17, 16, 15, 10 seconds. I think everybody answered. So random and far apart, it's gas. They are far apart and they are random, Doha, right? Yeah, so they are random. Doha, do you get it now? Look at the chart. Okay, double points here. If the volume is the same, which state has the most particles? If the volume is the same, this volume fits more solid particles, more liquid particles, or more gas particles. If the volume is the same, it fits how many particles? How many questions? We have 2 more, I think. I pressed the wrong button. Hands. Okay, 7, 6, 5, 4, 3, 2. Okay. Yes, solid, if you have the same volume, you can fill it with more solid particles because they are tightly packed. Okay? All right. Guys, if you want my notes that I used today to explain, just text me. You guys have my phone number, right? Okay. Anas Morsi is number 1. Wow, that's amazing. Double points, guys. In solid form, particles they have what? Strong bonds between particles, or strong forces of attraction between particles, or weak bonds between particles, or weak forces of attraction between particles. Guys, is it bonds or forces? Is it bonds or forces? Yes, Hala. Is it bonds or forces? Hala, you said, please answer me. How do liquids not fill the container? Because there are forces of attraction that are keeping the particles close together, Hala. Okay? Yeah, these are forces, not bonds. Bonds are something else. Okay, so it's strong forces of attraction between particles. All right, here is the chart. Look at this. Whoa, Judy, Rama, Maryam, Sifdin, and Ahmad? Is it Ahmad? Okay. In gases, particles have, this is the last question, guys. In gases, particles have strong bonds between particles, strong forces of attraction between particles, weak bonds between particles, or weak forces of attraction between particles. It's gas. It's gas. So it's definitely, you're welcome, Cameron. You pressed wrong, Hala. It's okay, Hala. Guys, did you have fun today? Was that fun? I love Kahoot. I use it a lot in my class. And it makes, yes, it's interesting and it helps you memorize and it helps you remember. 10-second, guys. This is the last question. Ruqayya, thank you. Maryam, thank you. All right. Yes, it's weak forces of attraction, not bonds. Thank you, Nadine. All right. Let's see. The top 3 are, Maryam is number 3. Congratulations. Guys, we had fun. I mean, it's not, Rama is number 2. It's not a competition. We're just having fun. And number 1 is Judy. Look at that. And then Saifuddin and Ahmad were number 4 and 5. Love it, love it, love it, love it, love it. You guys did wonderful. If you guys want my notes for today, these notes here, just text me. You guys might got my phone number, so these notes are here. If you also want your specific board examination notes, please also text me. I will send it to you. I love you all, guys. Thank you so much, and special thank you to Miss Saba, Miss Jenna, and Miss Dina for being able to be hosts here and helping with questions. Guess what, guys? Miss Jenna answered, you know how many questions today? 96 questions on the Q&A plus the chat. She's amazing. She's wonderful. She is the best. I mean, I consider her not just a team member, but a good friend. She's amazing. You answered all questions. You got number 5. Yassine, that's amazing. Congratulations. Thank you, Sharon. Wonderful. Thank you. Very interactive. Thank you, Sharon. All right, guys. Thank you so much. Love you all. See you next Sunday. I want to see you all on Sunday. Okay, do not miss out. All right, I'm gonna have another one next Sunday and 3 more Sundays. Okay. All right, guys. Thank you so much. Mwah. Love you all. See you next week. Have a wonderful Sunday. Bye. Have a good day. Bye.